Ohayo gozaimasu. My wife is tired of hearing me say that. My name is John, also known as Hodlbod. There's some stuff about me. I work on Coracle mostly. And today I am going to talk about relays. I retitled this talk a bunch of times. I was going to talk about gift wrapping and encryption and stuff, but relays are a big part of that. For supporting private groups. Do you use them? Do you ignore them? And as I was working on that, I kind of discovered some interesting properties of what relays can do and what they can't do, and a neat paradigm. So I thought I would just focus in on that and share that with you guys. We're a little behind, so I'm going to try to shorten my talk by a little bit here. But yeah, basically my talk is called Functional Relays, and that's a pun because relays have to work, and functional programming is a nice paradigm for making things work. So to get started, I thought I would start with the consensus definition of what a relay actually is. A relay is it really isn't much. There's not a lot that a relay does. It basically stores events, and that's the end of the story. They're interoperable, but actually defining that term is a little tricky. So I'll get into the details of what that actually means. But that's kind of your basic definition of a relay. Not all relays are equal, though. So relays can differentiate. You don't have to have just a whole bunch of relays that do exactly the same thing. And there's a few different ways that relays can differentiate from each other. You've got performance, so you can have a slow relay or a fast relay or a relay that has lower latency or higher latency. This is actually one of the main aspects that relay development has gone into so far is performance. You've got most notably stir-fry with its memory mapped data structures or data access, and that's blown a lot of the other relays out of the water. And so, another way that relays can differentiate is by behavior and what kind of functionality they support. So there's a few different NIPs that relays may or may not want to support. And then you've also got data set. So relays can contain different sets of data. You might have different data based on pub key or based on who just happens to write to it or based on content analysis. And relays have some tools for choosing what data set they actually support. And then there's availability. And what I mean by this is not uptime, but sort of interface. So relays are generally sit behind a WebSocket interface behind a domain name that resolves to an IP address. But you could equally put a relay behind a Tor onion service. You could put a relay in memory in your client application. You could put a relay behind a LAN, so you have to actually be on a particular network in order to access it. You might have a relay that sits in an app on your mobile phone that other mobile clients can talk to, sort of a local relay abstracted out. So there's a lot of different ways that relays can be kind of located. So let's talk a little bit about interoperability. Relays have to be interoperable in order to function well as kind of good citizens of the Nostr network. And the litmus test, I think, that makes the most sense is from an end user's perspective. If they take a relay and they plop it into their relay settings, then it should be able to make their experience better. And there are some caveats to this, like if you add 1 million relays, your experience is going to get worse. But just kind of keep that in mind, that a relay should provide some kind of improved functionality to a client. But of course, this can go along any of the other dimensions that I mentioned earlier. A relay might not have all the data that the user wants, but it might have some of the data and be able to access it faster, so like purple pages. Other relays might have no data that is commonly requested, so it might not respond to requests very often, but for occasional requests, like for encrypted messages or for very old data, that relay might be well suited to serve those requests. And so a relay can add to the user's experience of performance or data availability or feature availability. But there's some ways that you can do this wrong as well. So, behavior is a really sticky thing for relays because interoperability depends mostly on behavior. You can have different sets of data, and that doesn't break or hurt interoperability all that much. But if you have missing features or extra features, that affects interoperability. And what I kind of discovered thinking through all this is that with relays, extra features are actually worse than missing features. And that's a little counterintuitive because if you add an extra feature to your software, to your API, let's just say, and no one uses it, it doesn't really hurt anything. Whereas if you remove a feature from a standard interface, it does actually hurt things. With relays, I would argue that it's actually the opposite. Because if you remove a feature from a relay, we have other relays that we can rely on. So the client isn't actually damaged by that relay not supporting that particular feature. So, just to make it concrete, you've got request and you've got event. Those are kind of the two main commands that relays support. If your relay decides to just ignore event and throw a notice every time someone tries to publish to the relay, it doesn't matter because that's not the only relay anyone uses, hopefully. Same thing with request. Maybe you've got a relay and it's write only. Who cares? No one really notices. It just ignores all the requests, and those requests get fulfilled by other things. On the other hand, if you have extra features, let me skip ahead real quick to make sure I'm not getting ahead of myself. If you have extra features, for example, count or search, these are the kind of the two main things that I think of when I think of extra functionality that isn't necessary and is tricky to support, but there are other things. If you have extra features, it invites clients to begin to rely on those. So last week I opened a pull request to the NIPS repo to deprecate and or remove NIP45 count, which is the only NIP with exclusively my name on it. So I'm destroying my own contribution to the protocol, or in other words, cleaning up my own mess. I think NIP45 is a bad idea. I think count was a mistake. Because, the motivation for opening that PR originally back in March or April or something was, let's just see how we can support more advanced functionality on Nostr. That's not just getting requests and then counting them in memory on the client. So that was the motivation, but unfortunately it's just not implemented by most relays. There was rbr.io, which is now defunct, and Nostr.band, and those are the only two relays that I know of that supported count. And so if you want to get a count, you have to ask Nostr.band. That's extremely centralizing. Nostr.band has most of the events on the network, but it doesn't have all of them. So not only are you not going to get an accurate count, you have to rely on one particular implementation and service in order to get that count. Same thing with search. A lot of relays don't support search. And so you have to get your search results from certain relays. And search is actually really hard to support in a really robust way. You got to have full text search, often different services to support that. And we shouldn't make relays support search. Does that mean we don't get search? Well, I'll get to that. So extra features for relays are bad. Missing features are fine. There is kind of an exception to this, and that's when you don't support, or you support a feature of the protocol, but in a way that no one knows how to use. So Nostr is an example of this. Nostr is a search relay, but it doesn't support filters. So if you send filters, it refuses to respond to your search query. That's just non-standard breaking changes. So don't do that. A couple other things about interoperability. Data is optional. All data is optional. You can have a relay that has no data in it and provides no utility, and a user can add, following our litmus test, they can add that relay to their set, and it doesn't hurt anything. It doesn't help anything. But the threshold for being useful is that relay could just have one event. I don't know what one event could be worth adding a whole relay to your client, but I can see that actually being the case. Maybe it's an encrypted event that is the current key in a shared key scheme or something like that, some kind of dynamic relay. But you could have a relay with one event that actually has utility for the end user. So the flip side of this is that relays, I always talk about relay decommodification, and that's basically keep relays weird. Relays should not all do the exact same thing. They do need to be interoperable, but that doesn't mean they don't differentiate at all. And a big way to be able to differentiate is on that data level. So, moving from the behavior side of relays to what's actually available. And there's two basic ways for relays to do this. One is relays can scrape data from the rest of the network, maybe based on a pub key filter or content analysis, whether it's just topical or powered by AI analysis or sentiment analysis or something like that, and then suck those events in to the relay and then serve those as kind of like a read-only relay. This is kind of behind the Nostr.tools approach of adding keyword filters and stuff like that, and this can be useful. You add this relay, and you can go the global for that relay, and actually have a global view that makes some sense. You could do this with just rec, but of course that's really inefficient. So the negentropy protocol that stir-fry implements can be really helpful for this. There's some work being done to bring synchronization and hashing of event sets into the protocol. And then the other way to do this is through authentication. And that's kind of more useful for relays that actually receive events directly from users. So it's a relay that is closed and authenticates people who want to write to it or read from it potentially, and then keeps that data proprietary by preventing other relays from scraping that data. Because if other relays scrape the data, then it doesn't really have as much of a function as a read relay. So like an example of this would be for a community group where everyone who's a member of the community can read to it and write to it and no one else can, or maybe a publisher that writes to their relay, so only the publisher, only a few whitelisted pub keys can write to the relay, but anyone can read from it. So it's kind of the go-to for that like publisher. So getting to the functional programming side of this stuff, one of the best tech talks I've ever seen is Simple Made Easy by Rich Hickey. If you haven't listened to him, you should just go listen to all of his talks after this conference. He's brilliant and very fun to watch. And in Simple Made Easy, he gets into a critique of object-oriented programming, and he kind of coins or revives a term, an archaic term, the word complect, which basically means to braid together. And he says that that's where complexity comes from, is where you have different concerns that are braided together. And object-oriented programming is really good at braiding different concerns together. And he makes some distinction between some important things. So methods and functions are different, and state and values. Starting with methods versus functions. A method is just a function with state already baked into it. So, based on that definition, a closure could be considered a method. Objects are really just syntax sugar for closures. So you bake some state into the function, and based on that state, you don't always get the same answer out of the function. So it's no longer referentially transparent. You're braiding in this extra state from outside. So that means that your function is not predictable. It can't be cached. It breaks a lot of guarantees. State versus values, I think this one is really interesting. The difference between state and values is that state has a name. State is the coupling of a name and a value. So when I assign an array, like an empty array, to a variable a, I can print a, and it's an empty array. So a is the same value now as it was before. If I do a.push of something, and then I print a, it's now a different value. A is the same name, but it represents a different value. So this is mutable state over time. Whereas with values, if I have the value an empty array, and I compare it to a value an empty array, it's always the same value. If I compare an empty array to a non-empty array, then it's a different value. It's a lot less to think about and a lot less to worry about in terms of kind of things shifting under your feet. So to apply this to relays, relays are objects. When we work with relays, we're doing object-oriented programming. They have a name, and their state is mutable. We address this relay, and we ask it for a bunch of events, and it gives us some events, and then we ask it again, and it gives us a different answer. That's fine, but it's complicated, or it's complex. Kind of going back to the just some standard behavior of objects is you often have getters and setters. If you've ever worked in Java, you know that. So that's kind of the minimum behavior for an object is you have a name and you want to assign a value to that name or get the value out of that name. Getters and setters with relays are rec and event. Rec is your getter, event is your setter. And then you also get bonus points for auth and sync. Auth is just a guard on your getters and setters, and sync is a way to do bulk getter, basically. So just a quick note that names aren't necessarily bad. If we didn't have names, we wouldn't have relays, and we like relays, so that's good. A name, though, should not be confused with state. A name sometimes represents known state, but usually it doesn't. A name actually represents purpose. So what is this relay for? Who owns it? Where does it live? Who's administering it? That kind of thing. So these names are useful for use cases, right? So one-to-one routing. So, you know, Hodlbod.nostr1.com or something like that might be my inbox relay for the gossip model. And so you can see that relay's name, and you can see the description potentially in the metadata document, and you can know that if you want to reach me, you can write to that relay. It's also useful for many-to-many routing. So, you know, you've got christpill.nostr1.com. And I keep mentioning Nostr.tools. There's also Relayable. There are these relays as service services out there, which are useful for setting these things up without a lot of overhead. So I do recommend those, despite them being, you know, kind of custodial, but good way to get started. But christpill.nostr1.com just has a keyword filter, and it looks for stuff about the Bible and church or whatever, and then pulls it in. So you know what it is generally, but you don't necessarily know what events are actually there. Sometimes the filter is wrong, and you get stuff that doesn't actually belong on that relay. And it can also miss things that are relevant. So a name is really an approximation, and it's meant for humans, not for machines. Now we get to the meat of it. Events are values. Events are not names. They're not state. If you have an event ID or a signature or both, you always have the same value, and that is exciting. Hash and signature functions are referentially transparent. If you give them the same data, you get the same string out. The same thing is true of hash sets of events. You can take a whole bunch of events, concatenate their IDs together, sort them, concatenate them, hash them, and you know that you have the same set of events. This is how the negentropy protocol works. You hash a bunch of stuff, and you compare the hashes, and if they're different, you need to do another full sync. But you can chunk those syncs down so that you can reduce the amount of bandwidth and back and forth that you have to do to actually synchronize two relays or a relay and a client. And you know, so events don't mutate, except for replaceable ones. I'm just going to take the opportunity to dish on replaceable events. They were a mistake. Replaceable events break this paradigm. Not exactly, because the IDs are still referentially transparent, but if you're using the address tag, you don't know what the value of that name is. So you've reintroduced mutable state. So we should get rid of those. So if we have state, or if we have values abstracted out from state, we also need behavior. And DVMs are a cool way to reintroduce behavior. Alan Perlis, obviously, famously said it's better to have 100 functions operate on one data structure than 10 functions on 10 data structures. So applying this to relays, going back to the count and the search examples, count and search are methods on relays. They are functions that are attached to to the object. So they have this implicit mutable state, and they're also tied to that set of values behind that name. But it's really common, I mean, maybe even universal, to want to run functions on more values than is represented by a particular name. So count is just, it's almost comically broken. This was known when we put the spec together, and this is why I want to remove it. If you want to count events from 2 relays, one relay gives you 50 and the other relay gives you 100. You know 50 is wrong, but you don't know if it's actually 150 or 100 or 125. You have a range of between 100 and 150 that might be valid. So like, if you're 50% off, are you anywhere near useful? So count is bogus, but if we build a DVM that can count the values behind multiple names at the same time, we can actually fix that problem. It's an expensive problem to fix still because we have to do that synchronization. But if we have an efficient hashing and synchronization algorithm like the negative entropy protocol, that can actually be done. And of course, DVMs are free to keep caches and state themselves. That can be hidden away. So we're dealing with a stateful system, but we can apply a functional paradigm to it. So separating state and behavior allows the different components in the system to focus on what they do best. Thank you, Pablo, for DVMs. If we can move all the functionality out of relays, all the functionality that relays don't need in order to kind of curate their data, we can add more functionality more freely. We can have recommendation algorithms, and I think this is probably the right way to go with recommendation algorithms, rather than having services or clients do it. Farm it out to DVMs, because DVMs can also compete with each other, and that's already part of the DVM spec. There's an event kind for that, and Pablo also merged my count kind as well. So we have count on DVMs too, at least in theory. So that is my talk. I'm going to go ahead. I've got a minute to do a quick demo. Hopefully this will work. Last week I wrote my first DVM, which is an exciting experience. I highly recommend it. I built a little framework for adding DVMs. So let's see. Can you guys see this okay? Okay. Let me go ahead and make it bigger. All right. So let me just show you what the framework looks like. You basically add these handlers, and then the framework listens on some whitelisted just a list of relays for events that are registered, and then it farms that out to this onEvent function, grabs the handler for the kind, and then calls the handler with the DVM and the event. The handler is a generator that just returns a bunch of events, either kind 7000 or the result kind. So if we go back to our count DVM here, I've got handle count. It takes a DVM and an event, grabs some input parameters. Let's see. Let me show you my spec for count really quick. And that's 5400. So here's a couple of examples. We've got our content, and our content is just a list of filters like you do for a request. And you can add some tags to group things. I'm going to skip over that for the most part. So if your tags are empty, you just get a number back. But you can also specify relays using params. So if I say param relay, and then whatever, it's only going to search that one relay. So you can add multiple relay params to search to control which relays you're actually looking at. All right, so I have a little helper function, count with progress, but basically when it takes an event, it starts a subscription on all those relays. It deduplicates the events, adds them to a result, either object or number. If there's grouping, it nests the results. But again, not important for the purposes of this demo. So it just counts the events and returns that number. It's pretty straightforward. So I've got this working in Coracle in theory. We'll see if it actually works. But let me zoom that up. There we go. So I've got a helper function that does a DVM request, manages the subscriptions and stuff like that. I've got a couple different relays, and that's for the brokering the DVM request. And then I have some of those relay params down here in a group. I'm just going to go ahead and take the group off. And so we're counting reactions for this event, 7B0. Just for, oh no, it's a pub key. So anyway, it doesn't matter. It's some event, and it has a lot of reactions on it. And so on progress, it's a kind 7000 event. We'll just log the progress, and on result, we will parse the content and log that as well. And I messed it up. Does anyone see my bug? What did I do wrong? Exercise for the reader. Oh, I'm on the wrong branch, that's why. Yeah, seriously. Yeah. Commit to trunk. Okay, let's try this again. There we go. Oh, but I need to run my DVM as well. Oh, great. Well, I'll be done early. You guys can suffer through 10 more minutes of this, right?
Extreme pair programming.
Okay, so it's not working. So you can clap now. I know. I didn't try hard enough. But in theory, you're going to get, here, let me just simulate it for you. There you go. Now you can clap. All right. So that's my pitch. Any questions? I'm happy to debate this concept as well.
Are DVMs just a super slow way of doing it, though? You're like doing a lot of back and forth and waiting for a DVM to pick it up somewhere. Like, you kind of have to know there's a DVM waiting to pick up jobs like this, right?
Yeah, DVM, the slowness, the latency of all the back and forth is my main reservation with this approach too. Like an alternative would be potentially there's a NIP that people have proposed for advertising API endpoints, and it's just another way to do DVMs, but you directly connect to the server. Pablo probably has something to say about this. I think it can be pretty fast. We're talking latency, so we have the request that goes, and then the response comes back. If the DVM has cached a response, in the best case, where you're talking less than a millisecond to actually fulfill the request. So maybe you've got 100 or 200 milliseconds of latency. So I think this is feasible. And of course you compare it to the alternative. You're not going to use a DVM for a really simple operation. You're going to use it for more heavyweight things. So if we're counting 10,000 events or something like that, the alternative is actually downloading and counting those in memory. So I think the latency is acceptable and pretty minimal. Yeah.
I think for something like this, you wouldn't do the back and forth. You would just, the DVM, because it's something so simple, you would just get the result back. It's not like, oh, okay, you're going to get an invoice, pay this, and then I'll give you the results. It would just be, give me the count for this, and this is the number.
Right, yeah. Yeah, and you could maybe build a business model on this, but I think people should just run count DVMs for free. I think that's, it can be part of a bigger suite of services. So not too worried about the monetization side of this. Yeah. Any other questions? Comments? Hallucinations? All right, thank you.